My name is Ilya Masuch, and today our session will be dedicated to digital factory and smart manufacturing, facts and future of data economy, everything related to digital. And we have a very representative panel of experts. I'd like to thank the organizers, Rosatom, who gathered the people who we can talk to without any script, because they actually are capable of answering any question. From the very beginning, let me introduce to you Dr. Vidar from Egypt. He's head of Rosatom project, building a nuclear power plant. As far as I understand, that this is the second nuclear power plant to be built in Africa. One was built some time ago in South Africa, and in North Africa there will be another one to be commissioned very soon, and it will work for the sake of Egypt's economy and the economy of Africa in general. Ms. Sontseva, Digitalization Director of Rosatom, Yekaterina, is the one who is helping Rosatom to transform into a company that would be on the forefront of the IT industry, and I'm among the IT specialists. 7 or 8 years ago, Rosatom was far from being an IT company. Boris Glaskov, Vice President of Rostelecom. Rostelecom, that's the main center or agency which is digitalizing the society. It offers public services and services for cloud computation. Boris, this is the very right person to speak about the future of digital. Sergei Martinov, if I'm not mistaken, and I know him for many, many years, and know him very well. Just it was a slip of a tongue. He's responsible for industrial revolution in Rosatom. He creates the products, digital products for our industry, and also some products that we are exporting. He has a huge experience. He used to work for Siemens. He was dealing with digitalization there as well, and now he's working for Rosatom. Viktor Bespalov also used to work for Siemens, so it happens so that we have 2 people from Siemens. Now he works for KAMAZ, car maker, and he still is responsible for digitalization of the industry. We'll have a lot of practical questions that Viktor will cover, I think. Andrei Bezrukov, he's head of one of the departments within Rosneft. I know that he is a champion of digital solutions. A kind of a person who started speaking about the Russia's export potential, and he was head of different missions that were sent to Central Asia to create and promote Russian products in that region. Vladimir Shevchenko, MIFI rector, that's a kind of a think tank, a competence center for the nuclear industry, not only. And besides, we worked along with Mr. Shevchenko in terms of setting up the leading engineering schools across the country, and MIFI, his academia, was spearheading that initiative, creating advanced schools, engineering schools across the country. May I have my presentation, and following that I will proceed with the questions. The slide is very simple. The industrial development directly impacts the development of the society, starting from the Stone Age, then proceeding to other centuries. So we call them the centuries, the Stone Age, then Farming Age, or Agricultural Age, but these are not centuries. Every such period would embrace several centuries or ages. It was followed by industrialization, then digitalization, and nuclear age occurred at the very same time. And we called that the age. And now we are proceeding with the intellectual manufacturing, which has to make the whole society smarter and more intellectual. I suggest that we speak exactly about that, and my question goes to Dr. Vidar. And this is my first surprise that I've prepared for you. Welcome to Moscow. It's my pleasure. My first question, not to confuse the audience. You are head of the nuclear power plant project for quite a while, and that age of digitalization started back in 2015, I think. How did the use of digital technologies changed throughout that period, started from 2015? How deep the digital technologies penetrate into that new project? And I may say that you are using the most advanced state-of-the-art reactors that are available in Rosatom. We call that cutting-edge technology.
Thank you very much.
Большое спасибо за то, что пригласили меня, большое спасибо за то, что предоставили мне возможность поговорить о нашем проекте, как мы используем цифровизацию в нашем проекте. Но прежде чем ответить на наш вопрос, я хотел бы в первую очередь выразить слова соболезнования тем, кто погиб в результате ужасного террористического акта. Мы все против подобных терактов. А теперь отвечаем на ваш вопрос. Цифровизация играет очень важную роль в нашем проекте, поскольку это позволяет вывести управление проектом на совершенно новый уровень. В 2015 году, соответственно, мы приступили к этому проекту, и сейчас он выглядит совсем по-другому, в частности, из-за цифровизации. В 2015 году было подписано межправительственное соглашение между Египтом и Россией для строительства 4 атомных электростанций в Египте. После этого мы, соответственно, получили лицензию на строительство первой атомной электростанции в Египте до Басайде. И затем, через 2 года, мы преодолели первую веху, то есть, соответственно, был построен первый блок, первая очередь, в 2023 году второй, и, соответственно, в 2023 году, соответственно, мы ввели в эксплуатацию. И у нас, соответственно, в январе 2024 года завершили строительство 2 этапов. И почему это было так важно? Потому что на церемонии открытия присутствовали его и превосходительный президент Путин, президент Аль-Сиси. Египет приступил закончил строительство всех 4 очередей. Теперь, соответственно, мы приступаем к завершению этого проекта. Он будет введен в эксплуатацию уже очень скоро. Что касается цифровизации этого аспекта, можно сказать, что начался очень длинный путь, и мы начали наращивать наш потенциал, в том числе и с Россией, создавая информационную систему. Информационная система — это уникальный инструмент, который позволяет нам правильно управлять не только нашими ресурсами, но также планировать наши деятельности. И у нас есть конкретная проектировочная документация, 3D-моделирование, и это позволяет нам, соответственно, следить различные изменения, как это влияет на ход реализации проекта. Также мы соблюдаем все технологические требования для того, чтобы постоянно контролировать выполнение всех технологических требований. которые были приписаны специалистам в области стереостатных электростанций. Сам путь длинный и непростой. И мы будем совершенствовать этот цифровой инструмент, преодолевая разные трудности на этом пути, но также нужно отметить, что к концу этого года у нас будет возможность, соответственно, сделать такую визуализацию, чтобы мы могли рассказать о нашем проекте стереостатной электростанции и студентам, и посетителям разных выставок для того, чтобы повысить узнаваемость этого проекта в глазах населения. Этот проект важен для нас, для нашей экономики. Вот вкратце ответ на ваш вопрос о цифровизации, как мы используем цифровые инструменты в нашем проекте. Самое важное, мы, соответственно, используем цифровой инструмент для управления проектом, постоянно обновляем информацию, и есть даже такая то, что называемая приборная доска управления. Мы направляем соответствующие отчеты нашему руководству. Это сделано через цифровую систему, которую мы реализуем в рамках нашего проекта вместе с подрядчиком. Thank you so much. I know, Dr. Vidar, that you have to leave very soon. That's why I will ask the second immediate question before you leave. How do you see the development of digital component of nuclear industry, for instance, 10-15 years from now, exemplified by your nuclear power plant? 10-15 years from now it would be put in operation.
We believe that we need to rely more and more in digitalization in the aspect of data analysis, data collection, how we are going to move forward to support the decision maker. On the other hand, we need to have to be focused on that. We need to have the managerial decision makers based on people that have done experts, especially when we are dealing with the safety aspect and safety tools and safety system. We cannot rely on digitalization 100% when we are dealing about safety aspects. Yes, and this is the two main important that we need to digitalize systems, yes, but also we need to practice and train our people to make the right decision based on these analysis that used based on the digital systems.
которые нам генерирует цифровая система.
Шукран ктир.
Спасибо большое. Шукран ктир. Спасибо. Thank you so much.
Илья, я вклинюсь именно в этот разговор ваш, доктор,
get in between you and Dr. Vidar regarding the 5-year-long planning period of digital technologies in Egypt.
Та картинка, которую ты показал, ведь
I was caught by that slide that you have shown. Egypt is the only country in the world which has created a technological facility which surprises the whole of the mankind, and no one understands how actually it was done. I'm speaking about pyramids. I was lucky enough. 2 weeks ago, I was in Egypt and I visited the nuclear power plant and the pyramids. And actually, the road from the airport to the NPP goes next to the pyramids. So I managed to get some sightseeing there.
Я, конечно, не возьмусь прямо вот повторить, не возьмусь сказать, что мы должны прям целиться в
то, чтобы repeat what ancient Egyptians did.
Такое достижение, чтобы прям весь мир еще многие тысячелетия не понимал, как мы это сделали.
Or to create something that would wonder the whole world, but probably we can make something that the whole world would notice, would mark as a real wonder.
И должны себе такую задачу поставить.
I think that we really can do such thing. Make that another wonder.
Thank you very much. We believe as an Egyptians working in nuclear power plants authority and as a new Egyptian nuclear team that constructing and operating of a double project to present our fourth pyramid in Egypt. And this is the slogan or this is the message that we're sending to all our people that when they are visiting the double side that we by the Russian technology and by cooperation between as a partners, hand by hand, arm by arm, we are constructing for the operation of almost more than next 60 years our fourth pyramid, which represents
первую пирамиду. Это наш проект, который будет запущен и будет работать в ближайшие 60 лет. Well, I have to pay tribute to Egypt in the sense that I had a pretty medieval picture, but Egypt has documented a civilization about 5,000 years ago. And this is why we learn how the people used to live 5,000 years ago, and so the credit for that goes to Egypt. So we are very grateful to Egypt for that on behalf of the whole mankind.
Thank you very much.
Большое спасибо. Let me proceed with Kate. From the pre-medieval to our modern world, the smart society. It's very easy to ask Kate about digitalization. That's why we are not going to speak about digitalization. She is responsible for quantum technologies and quantum computation in Rosatom. Kate, last year, or a couple of years ago, a trend emerged where the use of the AI in the society. We know that AI has become part and parcel of our society through GPT technologies. This is for the first time that the people started asking computer, and it responded to them. And the computer does not provide accurate answers until today. But in terms of the industrial manufacturing, the computer has to provide exact and accurate answers. It should not actually suggest a gear which does not exist in the nature. How do you see the use of AI in the industry? How will it impact the future of industrial manufacturing, for instance? Again, the time is accelerating, and it had to last a century, but I think that the AI century would last only 10 years, and it would be followed by the quantum computation. Well, AI age would last for 10 years more, and it would be succeeded by quantum intelligence, and quantum intelligence would evolve even better. Regarding AI use in manufacturing and industry, in brief, AI in industry was being used since long ago. It was not actually publicly known. For instance, in B2C sector, AI was more noticeable. This is a sector which is being used by the people. There is even a joke regarding that, and probably it is... You all know that, but I got that quite recently, so let me tell you that joke. So a lady gets into an autonomous vehicle and she says, "Oh, how interesting it is, an autonomous vehicle." And the vehicle says, "Well, I'm an industrial AI and this is just my moonlighting." Part-time job. So AI is really being used in manufacturing in the industry. When I joined the industry, it already had been using AI to control where the individual protection units were being used, and machines were analyzing whether you have buttoned your overalls, whether everyone is wearing helmets. And I remember then
that was the first idea of collaborative artificial intellect, of the joint collaboration of machine and man. And for me, a good example is Mr. Shalnov, director on IT concern department. So when he was talking about when you violate the safety rules, so then artificial intellect would send text message to your wife, and by doing this, the level of literacy would grow as per safety rule application, as if we talk about interaction of AI and real men. So why actually we don't, well, why we know a lot about AI, or vice versa, we don't know. So at first, workers in this sphere are very practical people, and they're not eager to share their knowledge very easy and quick. And then when you use in any production new technologies, you have to spend some time and to wait for a while. So right now we've come to that point when we've accumulated a lot of pilot projects. When last year we took this decision that this time has come when we're not scattering stones all over the place in the direction of different technologies, but it's high time to collect those bricks and stones and to gather it up. So, and we realized that we have to collaborate with the best experts, world experts, and we shouldn't be in the closed circle, closed loop collaboration. And we've performed the whole range of different exercises, let's say so, for the research of the issues. What has been achieved all over the world in those directions of industry and production where AI could be applied, with what kind of economical efficiency, and of course it's understandable that in some processes AI gives like 200-fold increase of velocity and quality to some extent, but somewhere effect is not so significant, but it could be significant. However, it's not achieved yet, and we've accumulated and gathered up this big map on application and use of AI in different industries all over the world, because in Rosatom we have practically all kinds of productions, and last year, just for the interest, we had a look at the special economic codes which are being covered by Rosatom. So these are codes of products which it's like international trade codes, what we actually prepare for export. So 96% out of all these codes are used in Rosatom scope. So we've studied this experience and we've connected to the specialists which were making some pilot projects. And together with Higher School of Economy, thank you, colleagues, for your help for collection of different data on pilot projects in different spheres of industry. So we've joined it with our industry experience, and right now we're shaping the second map of application of AI in Rosatom on the basis of systematic approach, which transfer AI from pilot dimension application to the scalability. And I guess it's our peculiarity of nowadays. This is like a transfer of tests and mistakes to real-time use. And it's not only about Rosatom. You see, we're talking about general industry. If we talk about competitiveness of different countries, you see, competitiveness has been concentrated around the terms, timelines, and costs. And actually, Rosatom has been training on that thing, starting with construction of the plants, power plants, and of course, timelines are very crucial there. And now it will be also also belonging to some industrial goods. How much qualitative will be the products and some industry objects which will be competitive, have a competitive edge in the international level. You know those stories about microchips which are used in our computers. They're like semiconducting properties, but they were showing the best technological abilities of scalability of the production. So this is the choice of optimal selection and choice, and not always the best technical characteristic wins, but different attributes and signs are determining the success of some products, terms, timelines, and on and on. So that's why now the application of breakthrough technologies of AI, for example, quantum technologies, and we're starting to use them. For example, quantum algorithm for resolving some problems. Of course, now those algorithms are really small. You remember Games of Thrones? They have those little dragons, and everyone was able to offend them. And the quantum computers are similar to those little creatures. So they're still little, and they can throw some fire, not so powerful yet, but you see, actually this is the very technology which will flip the world upside down. Thank you, Ekaterina Borisovna. So in our digital Rosatom stand in the exhibition, there is a department of digit, and there is an interesting dummy of the production of cutting of the plastic material. Plaster. So actually, when you touch on this topic, they create some kind of a heating tablets, pills. You see, it's not just cutting some plaster, whatever. But yeah, it was cutting correctly this material until the sun was shining into the camera, and then AI stopped, and so we had to shut the sunbeam so that AI would react correctly. So, but we know that AI can work nicely in the sun and also has some sunburn. You see a reactor of one institute has this example that foxes are smarter than hares. You see, but foxes didn't eat hares and rabbits. Why? Because they couldn't calculate the route of air, because air actually doesn't know where he does run. So now another question. So data is a new oil. We've been working with Boris for a while, and at first, like 5-7 years ago, he was saying that people are new oil. So this was like this old school or kind of promoted term abroad. But you see, maybe bread is more important than oil, but usually, yeah, well, they compare the significance with oil. So you see, we have to keep this oil or this data. We have to keep them safe, we have to transfer them, we have to process them, and of course, because due to transformation of Rostelecom, before that it was only telecommunication company, but now it's a bit different, and within the last 10-15 years it has become advanced IT company. So, Boris, how can you see digitalization of the manufacturing facilities and data transfer, are you ready to process it? And as per my major specialty and from the standpoint of moderator, I would like to ask you, will it be really used? Well, as per processing, that's pretty fair that in serious enterprises, in the objects of critical infrastructure, those people who deal with security, of course, they understand that they have to keep this data as a bullseye, you see, and of course, this dilemma is very known, but because we lost the range of suppliers from the Russian market, many major corporative contractors or customers, we call them like that. Yeah, sometimes they say that it's better to have a segment in some major data center and to keep your data there than to create your own center. So you saw those pictures, two cubes in the end, like smart transformation, information, but I guess it's overheated a bit. This issue is a bit kind of overheated. So you were exactly right. So first we have to collect this data, then to keep them, to save them, to protect them, and then to transfer them. And here we have the issue ahead of us. Where we can get the funding to implement it, because digitalization penetrates industrial enterprises more and more, and that's why, of course, we are interested in this critical infrastructure which transfers this data and should be proven and confirmed and reliable. And in our IT segment in Russian market, it is rather good and favorable surrounding when we can go down to our own domestic solution. And you see, maybe it was difficult because we had different, not our solutions, but now this platform is rather good. I would like to remind you that all over the world, and not only also in Russia, they use special separated networks, especially dedicated grids. And because the market is growing drastically, and you know, those enterprises of such size, they have like 1,500 like numbers all over the world. So this network is completely protected, isolated from external networks, and it's very useful for big enterprise. And our technologies are not lagging behind from worldwide technologies. So we have pretty good growth, 28%, and it's like 1.5 billion rubles. But you see, it's not so, well, let's say that revenue of Rostelecom is 500. So this market is still small, but it's growing. And that's why developers of telecommunicative equipment, which should be embedded in this infrastructure, should be focused on B2C segment. It's pretty huge, has pretty serious cash flows. They can substitute foreign equipment into Russian one. And what happens in the private segment of the networks? I guess that the role of regulator is very important in that regard, because efforts of domestic developers could be adjust this picture, and it would allow us to use domestic technologies to promote it. You see, I'm sitting near the portrait of Igor Kurchatov. He is very serious academician and also kind of political person in Russia. And he was saying that we have to kind of chase ahead of our competitors, not chasing them, kind of that. So that's why he created hydrogen bomb, and I don't think that in telecommunicative segment it will work like that. Some people say that, yeah, we have the 5th and the 6th generation of the communication, telecommunication, and they say that we have to build it here, but we have to see the difference between those technologies. The 4th, the 5th, the 6th, they're not stand-alone technologies. They're interconnected. For example, it's like matryoshka, like one doll into another. So it's like foundation, and then first floor and the second floor, they're interrelated. So that's why Kurchatov's formula won't work here. So we have to come down this road by our own, and of course we have to analyze all the mistakes and errors, and we have to admit and we have to recognize that we have to perform this work. Thank you, Boris. Thank you that you've reminded us about Igor Kurchatov. He looks at us from that portrait, from that wall, and how we would transform our production intellectually. Maybe in IT technologies and in telecommunication, we could try to make a search of solutions which would allow us to be ahead of everyone, not chasing them, kind of that. So Sergey was working on old technologies. He was trying to keep the pace and to catch up. But in the middle of the last year, our government paid a lot of attention to the digitalization of the production, and the most significant thing at this thing was to create and to find our Russian solutions where we are ahead of some things, not trying to catch up someone. And we know that the head of our government is very much interested in this regard. We can compare him actually with Kurchatov, because he was kind of in that role more or less before. And so government approved this way of solutions, and they gave an order and decree to try this role in the range of our enterprises. What's your take on the future of those things? So can we have a look at the presentation? I prepared some slides. So actually the first slide is about Industry 4.0. It emerged in 2014. Actually, for 10 years, we've been developing Industry 4.0. And 10 years ago, I was very much believing that 10 years past, we would get smart production and on and on. Unfortunately, our life is a bit different, and it's locating everything on its own spots by itself, and the development is not so fast. And the essence of this 4.0 industry, that on every cycle of the goods, there is a development of the product, then digital twins are being made, and the data collection of the production is being made. So then we're making forecasting for the data, and then we create some kind of a smart production which can be self-regulated together with AI. And so where do we locate ourselves from my standpoint as of now?
Give me a second. I will scroll it back. The digital enterprise concept is clear for everyone. In 2014, the Industry 4.0 started. By 2016, now industrial enterprises, I'm speaking about space, aviation, started thinking about whether it would be good to introduce digital systems, to introduce IoT systems, industrial IoT systems. And this is since when the whole process went on. Before, it would be continuous manufacturing facilities that own such processes such as metalworking, for instance, or nuclear, but machine-building enterprises were lagging behind, although we promoted a lot to the market such solutions. And digital enterprise concept consists of 4 levels. At the lower level, for instance, when we create certain parts and components, we collected data from the CPU tools, we install robots, we make RFID tags in order to see how the parts are moving around the enterprise along the supply chain, and this has to ensure the traceability of all the parts that have been manufactured at enterprise up to the end product which has been made in real time, and therefore it would ensure a fast reaction to certain deviations. And starting from Tier 3 or Tier 4, there are ERP and other systems which, thanks to digital twins and data processing, would react to the changes in the production and would somehow introduce corrections. In 2014, such a concept was offered. Now the enterprises are moving along that way, but the progress is not fast. I thought that by 2025 we'll get such smart manufacturing technologies. Although there are some technologies which are close to that, and probably my colleague from KAMAZ will tell you more about that. In Russia, really, we have a lot of unique products. Speak about the world, nothing is going fast either, and we do not have such surprising milestones when autonomous production has been launched, or at least such cases are not numerous.
По крайней мере, эта история понятна для промышленных предприятий. Это вертикальная интеграция в рамках одного
that would require vertical integration within one enterprise, setting up digital production. But at the strategic session, we said that 4.0 concept implies not only automation within the production and the cycles, but along the whole cooperative links. And it was a very unclear topic. And back in 2014, 2015, I could understand how we could connect different digital enterprises within the supply chain so that we could react very fast to the changes in the overall situation. The suppliers, this is the bottleneck in any production, any construction. So the delays occur because of that. How we ensure the transparency of that, for instance. When one enterprise makes parts, another one do some assembly, and then it would be supplied to the end manufacturer of some end product. So certain logistics links have to be established. Within the strategic session, we suggested that our industry creates a kind of an integration platform which has to be put on top of some item, acting as a data aggregator that would engage the data along the whole supply chain. It would offer some services to ensure interaction planning and data aggregation and rendering of that data from one supply to another, from one supply chain to another supply chain. Along with that, it should be based on the model-driven approach, meaning that we have to have engineering data, digital data, because engineering process would engage a lot of contractors, subcontractors. When you design the aircrafts and trains, we have to exchange data, make some simulations, see where our interests cross. And as far as the enterprises, I'm working different information system and are creating their own digital enterprises. It becomes very important to exchange data between different informational systems at different levels.
Она очень важна.
That's very important.
Ну и это позволит, с нашей точки зрения, создать некий общий цифровой двойник самого производства
digital twin of the manufacturing facility, thanks to the global cooperation among the suppliers.
Это индустрия 4.0.
That's 4.0 industry, and we'll have to move forward towards that, creating some systems, optimizing our own production. Speaking about the factory of the future, and we started speaking about that back in 2016, 2018. An example of smart factory, Audi. The speaker told us that the conveyor belt assembly of a car is no longer efficient in today's realities. And probably you remember that back in 2017 it's been said that we will bet on customization. That means that we have to move to the modular assembly system. And the aviation and car makers are trying to move to the modular assembly system, for instance. There is no conveyor, but there is a kind of a trolley that would assemble the whole car. We are using the existing digital systems and SCADA systems. These systems have to communicate to one another. This is an automated assembly station. And it has to inform the system about what components are needed. And such cyber-physics systems have to interact with each other. As a prototype of the smart factory of the future Audi, for instance, is making test beds. For instance, there is a mobile assembly station with certain robots connected to that, and that station may move from one station to another, for instance, doing painting, and when the painting is being done, it may assemble something else, following an order or request from one station. Components would be supplied. There are autonomous drones, autonomous trolleys. This is a kind of our future. Back in 2016, it looked very realistic, but now we understand that this is a faraway future. And we have not come close to the industrial IoT yet. But nevertheless, we are analyzing some trial steps, what we can do.
И, наверное, там к рубежу 2040-го, я надеюсь, года, ну, такие производства появятся.
Well, I don't have that by 2040 such production facilities would emerge. Whether it is efficient or not, but I think that economic efficiency is something that we have to bet on. Whether we need the fully automated resources or not fully automated resources, unlike other countries. And some countries probably will not see any sense in moving to the fully automated production. Speak about engineering services. There is a kind of a cycle of engineering processes when you develop certain products to simulation, simulate the setup, the production, you simulate those technological processes. And all in all, that technology is more than 30 years old. This is about the parallel engineering. You take some master model, and it would go along the whole line.
Конечно, при внедрении не только у нас в стране, но, в общем-то, в мире огромное количество барьеров возникает.
But nevertheless, there are lots of barriers that may emerge. This is a paper-based approach. There will be gaps between technologists and designers, people who do not trust the electronic models, digital models. We have also some obstacles related to the red tape, to the regulatory obstacles. We have to introduce some 2D documentation. It can be done a bit later, but the effect would be achieved once you use 2D model, 3D model, and therefore the whole cycle actually would be somehow shortened or improved. In Russia, we also have such examples. Sukhoi Superjet, for instance, was certified.
Изделие 10 лет. Это уникальный вообще прецедент в мире. Еще никто такого уровня и скорости не добился. А просто потому, что Сухой
just because Sukhoi
модель-ориентированный подход на изделие Т-50, в общем, применили это все на Суперджете, и, в общем-то, полностью по трехмерному макету было создано изделие отсертифицировано. Это достигло очень уникальное сокращение сроков на рынок.
shorter, KAMAZ, ODK, etc. So in Russia we have lots of examples of such an approach.
Ну, как очень эффективный подход. Но
that could be called efficient. This is my last slide. And I'm done with that, I think. But in my point of view, there is a kind of crisis there, so that improves the time to market. But certainly you cannot somehow shorten the timeline several times. There are now breakthrough technologies that have emerged there.
Процессов управляющих программ для станков щепой и так далее. И с нашей точки зрения сейчас очень хорошее время. Может быть, это еще очередной хайп, я не знаю, но мы верим в то, что следующий этап — это искусственный интеллект для инженерных задач, потому что глобальные вендоры пошли в облака, потому что это интересная для них бизнес-модель, но и с точки зрения агрегации больших массивов данных,
following which they will be able to make certain models for the artificial intelligence.
Вот. И пошли они уже примерно 2-3 года назад.
And they moved to the cloud a couple of years ago. And obviously, the industry globally is reluctant to move to the cloud, but nevertheless, Daimler and some other are using their private clouds.
На горизонте ближайших 5 десятилетий появятся новые, совершенно новые прорывные технологии.
We will see some breakthrough technologies very soon related to the mathematical modeling.
Вот, в эту сторону тоже надо развиваться. И вот
we have to move this way there as well. And
представили, и вообще эта идея,
the integrational platform that we have presented at the strategic session with the Russian government, and it applied the aggregation of some engineering data, something that we can work on. This is what we are doing in order to accelerate the process. We're looking for startups, the companies that are doing something on the basis of the AI. If you are doing the same in terms of engineering, for instance, then I think we may have a very interesting communication so that we could use these technologies in our integrational platform. Thank you, Sergey. Sergey, in his presentation several times, mentioned KAMAZ, and KAMAZ is changing very fast. At the time, I drove KAMAZ along the embankment of Набережной Челны, and we rode a speed of 180 to 100 kilometers per hour, so it was not scary. I think that the pedestrians were scared, but KAMAZ is changing very fast. As a resident of Moscow, I may tell you that there are electric buses in the streets of Moscow, and the nameplate says KAMAZ. And yesterday I drove a car made by Rosatom along with KAMAZ, and that's an excellent car. The platform is Russian-made, 100%. And KAMAZ also contributed dramatically to that. So I pass the floor to Viktor Bespalov. Victor, the government decided and instructed you, Екатерina Borisovna, invented that Boris digitalize something and stores and processes. Sergey is, well, this is just like in the Garage movie. You are the lucky one, so here it is. Do everything what you want. What is the digitalization status in KAMAZ, and how do you see the development? Well, thank you so much, Ilya, for your question. I apologize for my voice. This is not because of COVID-19. I lost it during the session. But I cannot dodge my fate. KAMAZ was one of my first customers, who I started working with in 1992. Then, for 14 years, I worked with KAMAZ, representing Siemens. And now, thanks to Rosatom, and that was a very important invitation for me, when publicly I represent KAMAZ officially. So for 14 years, I was implementing something in KAMAZ as a vendor, but now I'm on the other side of the barricades. Well, Sergey told us in every detail about the digital enterprise, because I wanted to focus on the fact that probably it would make sense to speak about the digital enterprise rather than digital production. I will not repeat what has already been said in every detail by Sergey, and probably I will highlight several aspects, the very definition, so that we should understand what we imply by a digital enterprise. Digital enterprise, that first of all is a digital highway, one way only. So the data go this way, and the second lane is the way the knowledge has been passed. That data has to be processed and generated. And it's being used at every stage of data generation. At every stage, we have certain challenges, requirements, requests related to the market, first of all. And naturally, digital enterprise at every stage has to bring its advantages, its benefits. I will not elaborate on that, but as an example, for instance, if we take planning of the product for the automobile industry, that's a very relevant question, because all the products become more and more complex, more and more sophisticated. Leah has mentioned that, and KAMAZ is not the vehicle that you used to see in 1990s and nought years. At the moment, that's a vehicle full of software filled with different systems, and it has to meet the market terms, market conditions. Therefore, probably we have to make an engineering of the customer, so it means that a customer comes to us, and scientific and technological center would develop a model of a car following the requirements of the customer, and then the manufacturer would do that. But it is very expensive. We have to learn to design a vehicle following the configuration to order model. We have to meet certain requests and requirements, but therefore it would be less costly. If you make a tailored think this is one thing where you are flexible enough. That's another story. KAMAZ is following the second approach. Another example, for instance, if we move by the stages of creating added value and engineering. Product engineering, for instance, I told you already that the products have become more and more complex. And these are the consumer properties that are defined not by the mechanical properties, but by the electronic properties and by the software. The share of the software that defines the innovative nature is enormous, and KAMAZ is no exception. It is not enough to provide for integration of PLM system, email system, something which is responsible for the management process. KAMAZ already did that integration, for instance. So we have introduced PLM and MLM systems. And at the final production stage, we introduced end-of-line system, which ensures that the code is put inside the system, whether this is a truck and lorry or this is some new piggyback truck, something which is being made for the logistics needs. So a digital enterprise, first and foremost, this is an informational highway with data circulating, and these would be digital twins which move from one stage to another stage, and that has to be integrated. A few words about what has been done in KAMAZ.
While I was preparing to the speech, I was trying to touch on my old data. And you see, actually, we've been doing it since 2020-some. So actually, KAMAZ was implementing it by blueprint from stage to stage, and we started to implement it in 2021. So we had the approach of 100% approach, and after that we've come to the production, the implementation of automated complexes, and the efficient management of the equipment, fleet, and managed logistics in pilotless manner. And when we've come to the development of K5 machine, and from the very beginning, they said that this very truck should be connected. So there was a system of the digital services, and right now this very model is provided to the users, and right now KAMAZ provides the service of driver education, where the driver can be put in some adjustment in the way of driving, so that drivers would be very safe, and also there is a fuel efficiency, which is very important for the customer. So that's why KAMAZ implemented this very approach of the digital enterprise, and you can see it was from 2006 to 2023, but it was very consecutive, very exact. And the last stage was the project of digitalization, which was implemented. We had this task of production of K5 machine. When we're talking about PLM, ERP, and MET systems, they were united in 3 points, so like a golden triangle scheme. So we were not agreeing with Sergey. However, I can use some data of McKinsey company. So this data was analyzed. It was from 8-9 different industries. For example, where this efficiency of AI is the highest one. We can say that it's a hype approach. However, I'm taking it as the further development of digital enterprise. So from standpoint of effect given by AI as the means of business analytics, automobile production stood at the very high level. You see, KAMAZ, to be frank, is very cautious in moving in this regard because we're just testing the ground. For example, Sberbank was using it in their checks. And we were looking at the outcome of AI engineering in KAMAZ. So we are looking for optimal solutions when we're talking about setting components, then engineering solutions. And another topic is the use of AI in norms and reference inquiry information. So we know that there was a lot of data which was collected. So that's why we wanted to use this data, and we used it in AI. So as per technological audit, there are a lot of applications as well where we can use methods of AI site. So we can see the overvision or overview or like inspection of some operations or violations of some rules of some application of operation. Today was a business breakfast for digital twins and preventive service of them. So in my mind, there is a huge future behind it. So we were talking about Industry 4.0, but it didn't go further as per Internet of Things because they didn't have enough tools to collect the old data. But here we will connect AI and Internet of Things, so that's why it will work properly. Thank you very much. So it was very interesting, and hopefully we will see different little Kamaziks. It's like those little dragons. You see, this is not a KAMAZ project. It's a private investor project. When we talk about Atom, well, KAMAZ was participating in it somehow. No, there was no participation in this project. Okay, Andrei Olegovich, we are coming down to you. So here we have academician scientific block. You see, digitalization.
Цифровизация пришла в общем, со стороны Запада.
So it has come from the Western direction. So even Industry 4.0 is the Western term. And actively we started to use those terms. And even we achieved some success in application of the technologies. Because I've been dealing with import substitution and IT issue for a long time, so that's why this domination, like the prevailing in IT and in other regards, would be used in some political and not only direction. And we shared our opinions just recently. Autodesk, Microsoft, and others wrote the letter to the Russian customers. For example, Boris is one of them. Stop. It was written there. Please stop right away using bought software by you. So this kind of innovation in the world, you see. So, what do you think about that? What Russia should implement and what Russia could offer to the world as per approach of such digital technologies in everyday life? Can we add something? Can we enrich it somehow? Thank you very much for your question. You see, I won't tell you anything really good. You see, it was like we had good discussion, but then we've come to Bezrukov. Well, at first reacting to all these letters which our company received, so we have to send them to all the companies in the world so that everyone would have this letter on their tables, because it kind of encourages to look for new suppliers. Your head starts to work better. What would happen with me, and on and on. So that's why I would like to look at our discussion about digitalization in the context of everything what is happening around us. So we are coming to a new technological cycle. We haven't been reaching it yet, but there was a huge redistribution and split and kind of leap ahead. So 150 years ago, we jumped from like horses to airplanes, jets, to UN, with huge crisis, and on and on. So I guess that next 20 years won't be prosperity time, but more of surviving time. So that's why we have to look at the system, how everything is set, because there is a huge investment in AI, we can see that, and quantum cryptography, and it will give us completely different, it will require completely different protection and security of all the systems and all our approach of what we're doing. For example, there are a huge number of military systems which is using satellite information data. And until war stage in some acute stage, so everything's working. But if it's more acute, so then everything will touch some satellite groupages, and then we will have a look at a simple officer, whether he can read maps or not. Can he calculate according to all tables, like trajectory of the like military shooting of some real strikes, and on and on? So, you see, it's kind of hypothetical. However, you know, in any transfer, there is some kind of a non-determination. So, you see, when we had this transfer, we can see a huge legacy system on every leader, especially legacy mentality. I would say that ahead of our country, we have a huge perspective and promising platform of the leap ahead. So with our mentality, mindset, we can be, when we're really put into the corner, we have to survive, we have to stand for us. And we have to understand that if we're in we're entering new technological site, so then we don't know what kind of system would be optimal. We're looking at Anglo-Saxon system, then on Chinese systems, then other systems will emerge, and the competition of those systems will be the competition of worldwide ecosystems. There won't be any global system, because states and technological, economical blocks won't be competing. They have to be joined in some kind of unions to make good cash flow, to create new infrastructure, new society, and to provide well-being, and on and on. And every block of this kind will have its own digital ecosystem, which will be built differently, considering competitiveness of this system. So that's why we have the task ahead of us, with whom we would build our technological space, because standing alone, it won't be proper, it will be very challenging, and we don't have such a volume of the market where we can build up large companies and we can make a good return on investments, and we have to get some alliances and some kind of partners. It could be India, Iran, it could be Southeastern Asia, but right now we have to think about the fact that we have to construct standards of the platforms which will go beyond our country, and we need some technological partners and allies which would develop it with us for us to move ahead into new competitiveness. And so here we are talking about technological alliances, with whom we would build them, what kind of principles will be there. And so, you see, black box won't be bought in that condition. It should be some kind of a common development, common thought could stand behind it. And I would determine two stages of this game. You see, first stage, which is must do right now. Of course, it's our kind of digital household. So we have to make some kind of agreement with our partners to resolve this issue. I won't go deeper into the specialist understanding. So on this foundation of the technologies which we're talking about, we are able to resolve it. We're talking about cybersecurity. We have to build up a system with the right understanding that this system will be able to hold the hit, and it should be built according to that principle, even if system admin would come with the flash drive with virus, so the very administrator won't be able to kill it, you see, because the requirements of the next cyber war will be as such. So that's why all the potential of Rosatom and of Russia should be considering it. One of our largest expert blocks is the critical infrastructure. Why? Because our mindset has grown a lot from defensive, like country fortress. It's still there in our mind, in our brains. In all countries, it's like that about us. But many countries, they have a completely different historical way, and they don't think about that. And the market of critical infrastructure is the largest in the world. Of course, we're including smart city, because in 30 years, every city will be smart. What does it mean? Non-killable digital platform, where you can use it like Lego system. Any solution could be embedded there and put on it. So if we enter this market properly and we would build up our strategy in smart ways. So at first, it's the most technological and the biggest money-wise market in the world. And in terms of the political segment, we have a big share, because here it's been resolved like foe and friend principle. So you won't buy anything from the market which is related to your critical infrastructure. And Russia has a big share in it. You see, block of critical infrastructure is the closest to that market which Rosatom has now. For the reason that Rosatom has grown from the very beginning as the company where, let's say, no fault is tolerated. This is the phrase. You can't allow any mistakes and errors. So this system should be kind of very rigid, very tough and secure. And this mentality, this mindset where security and safety is the first line issue. Because in that market of critical infrastructure, there will be three types of companies. At first, IT companies, they have this mindset of kind of the quicker the better. Yeah, let's run and then we'll see the client and on and on. The second one is Siemens and Johnson Controls and all the rest of the world. So they are moving there and they're bringing their mindset legacy. And the third echelon, like companies like Rosatom, it's security, it's defense thing, it's. And then there is this kind of mentality, if there is a rocket or missile in the submarine, it should fly from there anyways. And so this is like a critical infrastructure mindset of the company. 300,000 workers in Rosatom, if they understand that there is no safety and security, so there is no business ahead of them. So this is the most important thing. Thank you, Andrew. Yeah, we've been talking a lot about people, about new oil, and you've mentioned that a man should be able to use math, physics, and on and on. And now we're coming to Vladimir Igorevich. So how about tables of Bradis, and do we need them? Because we've created the generation of winners. There was a generation of builders of communism, of the nuclear space projects of Russia. And now, most probably, we have to bring up the generation of digitalization, how our academician circle and students live now. How do they feel? And do you teach people those Bradis tables? No?
Well, let me divert from the topic. Once I was awarding the winners of the Olympiad on nuclear technologies. This is our core audience, the people who would like to get enrolled in our university or in some other universities. And I have 80 kids, grade 9 and 10, so not just physics, but nuclear technologies. 80 kids, grade 9 and 10. I asked them to raise a hand, those who watched the movie 9 Days of 1 Year. None of them watched that movie. For me, it was a surprise. I thought that at least there would be 4 to 5 hands. And half of them watched Oppenheimer movie. Back to your question that really the generations are changing. Certain things that we believe are cultural reference for us, for our generation, in that case, are no longer intact, and certainly we'll make them watch that movie when they become our students, but that would be a different story. But still, there are certain things that you have to do the very right moment. If until age of 15 you have not read Kashtanka by Chekhov, age of 30 it is too late, other books have to be read. But in that sense, I would like to proceed from your Bradis tables. So this is a really important thing. Bradis tables, this is where the squares have been indicated. We know that the decision-making support systems that help us to address certain intellectual problems are developing not for the first decade, not even the very first age. And those systems, on the one hand, improve the efficiency of our activity, but at the same time, they narrow our focus, narrow our understanding. Means that we are teaching arithmetic, although we understand that any adult would not actually sum up anything in his mind. He would use a calculator, then another question. Actually, the indefinite integrals, are they needed? Several decades ago, it was a part and parcel of physics that integrals have actually to be solved in Landau. Our physicists actually would suggest any applicant to solve the integral. And now, our software actually may solve those integrals much faster than any textbook would do. Does it mean that we don't have to teach? Probably not. Then, question about the structural performance of materials, whether we have to instruct the strengths of materials. And so there are critics of that, and there are opponents and proponents. Everyone believes that, well, there are some people who believe that strength of materials is inside the software. We have to teach people how to use that software properly. And artificial intelligence and machine learning are also part of that process. The key question here is who determines the structure of the space in which that optimization takes place and the functionality that we optimize. That's an external system, and it has to proceed from some axiological principles. What is valuable, what is not valuable. That's a humanitarian story, rather than engineering or mathematical problem. And the key thing in that respect is to retain a number of people who would share that value of understanding. Because unfortunately, in the framework of the process that I've mentioned,
очевидно, что значительная часть инженерно-технических блоков
part of the engineering blocks would be the users of those systems. They won't know what is inside these black boxes. Probably they would believe that if that black box was delivered from some friendly center, then probably it would work well. But I believe that this story about retaining people who not only would push the buttons but would know where the wires are going to, this is our key objective. And also this is a key objective to ensure safety and security. You can use smartphone being grade 2 without knowing the science which is inside that black box. But you cannot do the same to the nuclear reactor. You cannot do the same with the civil aircraft. And it means that you have to motivate the people to learn the multiplication table in grade 1 and to solve integrals in grade 10. And certainly you don't want to do that because there is a pressure of the market that immediately you become the user, and then you follow that user's trajectory without deep diving into that. Or you develop your own company. And for instance, there are lots of IT students who have portraits of Steve Jobs or There are students with the portraits of Extreit and Delvirkt on the walls, and there are more numerous people who actually would worship Steve Jobs. But we need more people who are knowledgeable about what is inside these black boxes. The quantum computing and other things would help us to solve those equations at a totally different level of energy consumption, because on the way up the ladder, we consume more and more energy, and it would cut off this part of the population have no access to cheap energy. We are consuming energy a lot, and it will not last forever, and has nothing to do with the carbon neutrality, but just the processes cannot work any longer because actually they are heating very much. That's the key thing. We have to retain that value of understanding in our training program. Thank you. Thank you so much. Thank you, Vladimir. In essence, I'm looking around and I see Sirius, MIFI, Rosatom. Well, that's good that we have gathered here. And even by the panelists, we see that we know which way to move, and you don't have to copy and paste, as we were told. We don't have to catch up in digital technologies. We have to look ahead, as Kurchatov used to put that, and to implement the potential that we have here in Russia. And I've mentioned advanced engineering schools, and Vladimir is in charge of them. That's great that you have such a viewpoint, and we're about to conclude our session. Should you have any questions, you're free to ask them. And if not, then I will have the last request to Ekaterina. As far as she stands up for thinking and ideology in Rosatom, what are the three areas that have to be the distinguishing mark of digitalization? Three takeaways. I asked a question about good mathematicians and physicists, and probably that goes the same line. Number one, the first competence that the digital industry has to be marked with, that's the ability to master and to introduce everything new. And I don't mean the ability to learn, although a lot's been said about that, and we are discussing a setup of a new university which will have no graduates. So it means that a person who is enrolled will never graduate from that, because this is a lifelong education. That person would get some certificates with some documents, but the training process has to be continuous, has to be lifelong. So this is our concept. And I know who you replicated that from. I know who used to say you have to learn, learn and learn. And you have to learn, learn and learn the military affairs the right way. Well, the industry should not lose its safety regulations, but it has to learn to master new technologies and implement them into the production process. Skipping some of the stages where this is technologically possible. This is exactly the new mentality that has nothing to do with the digital, because if we look further, there will be the question of using new materials, using new technological production
для цифры это абсолютно
materials, but for digital this is absolutely important.
Это первая тема.
This is number one.
Она на самом деле главная, потому что из нее
And this is most important because everything else would proceed from that. But speaking about
о конкретных технологиях, я хочу сказать, конечно, у нас кратно недоиспользованы те технологии, которые относятся к 4.0,
technologies related to 4.0 probably. We pretended that this is already left in the past. This is no longer cutting edge, but full-fledged use of the technologies. That's about VR and computer vision, the whole set of technologies that are included into the roadmap of our strategic development 5 years ago. It certainly made a boost, but we have to pick it up. Second thing I'd like to mention is we have to fully use what is available. Probably that would contradict to my idea to skip some of the stages, to move forward. Some of the ideas should not be skipped.
Потому что иначе оставим темные пятна за собой.
We would leave some undiscovered places on the way.
Наверное, знаете что, вот я тут взяла записывать какие-то...
I took some notes. Well, actually, the session was quite useful in the sense that suddenly we have to praise ourselves. Otherwise, no one would praise us. While we were talking there, a lot of ideas occurred to me. For instance, I even came up with what we can do, for instance, for the Egyptian project. But I failed to discuss that with Dr. Tvidar when he was on go, so let us leave it for some time. But when Vladimir was speaking about the value of understanding, I would actually make that top priority. I would actually put that on the wall. The value of understanding is clearly very important. Now, well, some knowledge is not demanded for, but this is a false idea. Who is going to make those black boxes? We cannot minimize the number of people who are going to make those black boxes that would later on would be widely used for designing by the people who do not know SAPR.
Людьми, не знающими, тоже не знаю что. Прям в голову сейчас какие-то яркие... Ну, с САПРом прекрасный пример.
SAPR, that's a very good case.
Еще прекрасный пример с лоу-кодом. Вот это же та же на самом
the code, that's another thing.
Развиваются лоу-код-платформы.
The low-code platforms are being developed and everyone would become a programmer, a software developer, but who is going to make those low-code platforms?
Ну, в каком-то смысле
всегда были программисты
на языках верхнего уровня, программисты
software developers at the high-level languages and at assembler language. But the value of understanding this is something that we have to contemplate on. Okay, thank you so much. I associate myself with what's been said, so the panel was very interesting, and I'm working for that industry, so this is my just moonlighting. So this is my public work. I get no money for that. So the panel was very interesting. And in essence, we can... Actually, I regret that ATOMEKSPO is so short, just 1.5 days. So let's next year arrange that for 3 days. And then probably we will develop some common understanding, common approaches. и она, наверное, пойдет в жизнь. Спасибо всем.
Thank you so much. Thank you so much.